So we're looking to calculate this limit numerically, algebraically, and graphically. So let's start with numerically with the graphing calculator. What I'm going to do is I'm going to go to my y equals, and I'm going to put this in as a graph. Now you do need to separate your numerator and denominator with a set of parentheses. So then I've got 2 plus x cubed minus 8 and my numerator divided by x. Now, we'll make sure our table set is correct. We want our independent on ask. And I go to my table, and I'm going to delete out what I had before. Now remember, I want this limit when x is around 0, so I'm going to put in points around 0. So I might put in 0.1, 0.01, 0.001. I could try putting in 0, but I'm going to get an error because 0 made the denominator of my expression 0, which gives us an error. Now those are to the right of 0. Let's talk about to the left of 0. So we might do negative 0.1 and negative 0.01 and how about negative 0.001. What we see is once again they're getting closer and closer to 12. So numerically it looks like our limit is going to be equal to 12. Now let's go ahead and calculate this algebraically and see what we end up getting as soon as we focus in here. Okay. So what we're going to need to do is multiply out the numerator and simplify. So this is equal to the limit as x goes to 0. Now this is not 2 cubed plus x cubed. This is 2 plus x times 2 plus x times 2 plus x minus 8 all over x. Now what we would do if we want to multiply this out by hand, if you know the binomial theorem you could use that, but if we're multiplying it out by hand, we'll FOIL 2 of them first and then distribute. So FOILing these two, we're going to get 4 plus 4x plus x squared times 2 plus x. And then we get this minus 8 we're going to have to take care of later. All over x. Notice each time I'm writing the limit as x goes to 0 because we haven't taken the limit yet, so it does need to be in there. Now if we multiply these together, 4 times 2 is 8. 4 times x is plus 4x plus 8x plus 4x squared plus 2x squared plus x cubed minus 8 all over x. So now we simplify, combine like terms, and see what we get. Well, those 8's are going to cancel. And combining our like terms, we have 12x from these two, plus 6x squared from these two, and then plus an x cubed all over x. Now in the numerator, we have a common factor of x in all our terms. So we can rewrite that as x times 12 plus 6x plus x squared all over x. That's going to allow these x's to cancel. So now, our last step in calculating our limit is going to be, we have the limit as x goes to 0 of 12 plus 6x plus x squared. And plugging 0 in for our x's, that zeroes out, and we get 12, which confirms what we saw numerically. Graphically, you could graph in your graphing calculator. I got a little bit bigger graph here for us to look at. Again, you see what's happening as we come in towards 0. So here's 0 on our graph. It's undefined there because 0 made 0 in the denominator. As we come in from the left, our y values are approaching 12. As we come in from the right, once again, our y values are approaching 12, and we can see that the limit to the limit that we were given is going to be equal to 12 because as our x's get sufficiently close to 0, our y values approach the value of 12, even though the function's value at 0 is not 12, it's undefined.